Welcome to Maths and Science by IITian channel. In this lecture, I will be discussing a very important topic of behavior of simultaneous equations, which is very vital in linear algebra, especially for JEE Mains and JEE Advanced and in Maths Olympiad. JEE Mains and JEE Advanced, this type of questions are frequent and regular. And I will be discussing about the simultaneous equations on the basis of the row and column elementary operations and whether the given simultaneous equations are consistent, inconsistent, no solutions or infinite solutions or with unique solution. I will be explaining it with some example. In the last class I have explained the process. In this lecture I will be taking an example at JEE Mains or JEE Advanced level and we will be solving it together. That's a 3x3 matrix with some variables alpha and beta in them, and under what values of alpha and beta the particular simultaneous equations behave for unique solution, infinite solution and inconsistency. These things we will be discussing. The question is, discuss behavior of simultaneous equations system given as Ax is equal to B, where A is equal to 3x3 matrix, 2, 1 minus 1, 3, 1, 2, 41, 3, 1 alpha, and B is equal to 5, 6 beta, and X is equal to X, Y, Z. We have to find for what values of alpha and beta these equations will become 1, will have a unique solution. 2, they are with no solution, and third, they have infinite solutions. We have to find the value of alpha and beta for which the system has got a unique solution, the system has got no solution, the system has infinite solutions, and this type of questions will be given in multiple choice questions in JEE Mains and JEE Advanced, and in JEE Advanced they can be given even with multi answers are correct. And it's a very important question. Please have attention to it. See the video till the end. Let's go for it. We will take up case 1. If the system has unique solution, what should be the condition for alpha and beta values? Condition is, as per the previous lecture on this topic, we have discussed that condition should be for a unique solution R is equal to R dash is equal to N. That means rank of coefficient matrix should be equal to rank of augmented matrix should be equal to n, the number of, this is R dash, the number of variables. Here what is variable? N is equal to 3, because there are 3 variables. X is XYZ, X matrix. N is equal to 3. Now we have to take rank of augmented matrix, we have to find out. Then we have to find out rank of, not augmented matrix, rank of A, then rank of K. This is K. K is the augmented matrix. Now, before finding the rank of matrix A, if rank of matrix is less than 3, then the determinant will be 0. If rank of a matrix is less than number of rows in original matrix, that implies determinant. That means one row is totally with 0 elements. Determinant of A is equal to 0. That means either you go by the simplification of row and column elementary operations, or you go for finding the determinant. Because it is a square matrix, the matrix, what is the coefficient matrix? It is 2, minus 1, 3, 1, 2, 41, 3, 1, alpha. If it is a 3 by 3 matrix, if rank of A is less than 3, that means determinant is 0, because one of the rows is totally with 0 elements. For this definition, please refer to my earlier lecture on this. Now, let us find out. For a unique solution, determinant of coefficient matrix should not be 0, or rank of matrix A should not be less than number of rows in original matrix. Both the ways we can find. It is should not be less than. Both the ways we can find. Both of them are almost, both of them are even though literally not, but practically they are same. Now, let us find out determinant of A. 2 into 2 alpha minus 41 minus 1 into alpha minus 3 into 41 plus 3 into 1 minus 6. This is a simple arithmetic which reduces to determinant A is equal to 5 alpha minus 220. You please do this. This you do. That implies alpha, 5 alpha is equal to 220. that implies alpha is equal to 44. If determinant to be 0, alpha is equal to 44. What we wanted is determinant should not be 0. For unique solution, determinant of A should not be equal to 0. That implies alpha should not be equal to 44. What is the conclusion we are making here? If alpha is not equal to 44, then the system has unique solution. Provided consistent and unique solution means provided for consistency the rank of the augmented matrix should be equal to rank of the coefficient matrix. Now what is the augmented matrix K? K is equal to 2 minus 1, 3, 1, 2, 41, 3, 1, alpha. Here we have already found alpha is not equal to 44. Hence, this matrix is already found out that the rank of the matrix A is already 3. Then, what is the augmented matrix? We have to write constants. What are the constant values? 5, 6 and beta. If this is B. If this is, please listen to me carefully. If this is rank of A is equal to 3, it implies the whole row, any row you take, all rows of K will be non-zero for any value of beta. The reason being 5, 6. If this is, for example, this row is non-zero, this row is non-zero, this row is non-zero. Then suddenly the augmented matrix K, any row cannot be 0. It will be non-zero only. Hence, rank of K is also 3. It implies rank of A is equal to rank of K is equal to 3 is equal to n. That is number of variables. This shows the final conclusion. Conclusion 1. If alpha is not equal to 44, the system has unique solution. This is one conclusion we have got. Now, case 2. No solution. Let us study. For what value of alpha and beta, the system will not have any solution. The augmented matrix K is equal to 2 minus 1, 3, 1, 2, 41, 3, 1, 44 and 4, 5, 6 and beta. There is no solution if determinant of A is equal to 0. That means alpha is equal to 44. We have written alpha value here. But that is not alone sufficient condition. For no solution, the system should have rank of, it is A, it is B, the whole is K. Rank of A should be less than rank of K. Then only it implies no solution. Now, we made rank of A as 3. Determinant we made it as 0 by putting alpha is equal to 44, determinant as 0. We have to find the rank of A. We have not made rank of A as 3. We made determinant A is equal to 0, means rank of A is less than 3. And what happens to rank of B? Rank of K in this condition? Let us start elementary operations. What we have to do for elementary operations? We have to make the first column, second element and third element as zeros. For that, what we require? R2 minus half R1 R3 minus 3 by 2 R1. Once we perform these operations, you can get, and we have to operate one by 2 of R1. First we will perform 1 by 2 of R1. What happens? Let us see. Very simple. Just don't worry, it's a very simple question. Because we are going in a detailed way. 1 by 2 R1 means 1 minus 1 3, 1 minus 1 by 2, 3 by 2 and 5 by 2 for the augmented matrix. These operations we will not simultaneously do. Once we have done R1 multiplied, then afterwards we will go back. Then 1 to 41, because when we are operating 1, we should not do again simultaneously with others. 6 and 3 1 44. Beta. This is the augmented matrix. Now, it will be easier for us. Then, now what we will do? R2 minus R1 and R3 minus 3R1, the modified R1. This is the modified R1, which implies this will be 1 minus half, 3 by 2, 5 by 2, this is 0, this is 0, then 2 minus minus half, that will be 5 by 2. This will be 41 minus 3 by 2. 41 minus 3 by 2 will be 62, 82 minus 3, 79 by 2. We will draw a line here because it is an augmented matrix. Then 6 minus 5 by 2 minus 7 by 2. Be very careful in doing the arithmetics. Six minus 5 by 2 means it is plus 7 by 2. Now 1 minus 3 minus 1 by 2. That means 1 plus 3 by 2. 1 plus 3 by 2 is 5 by 2. Then 44 minus 3 into 3 by 2. 44 minus 9 by 2. 44 minus 9 by 2. $79 by 2. Then beta minus 15 by 2. Beta minus 15 by 2. That implies, next what we have to do? We have to make this as 0. For this, for the detailed procedure, please refer to my earlier lecture. R3 minus R2. This will be 1, 0, 0, minus 1 by 2, 3 by 2, 5 by 2, 79 by 2, line is to be drawn, 5 by 2, 7 by 2, R3 minus R2, R3 minus R2 it is 0, R3 minus R2 it is also 0, then R3 minus R2, R3 is beta minus 15 by 2 minus 7 by 2, beta minus 15 by 2 minus 7 by 2. Then you see the final conclusion, it's very very important from it. What we have got is 1 minus 1 by 2, 3 by 2, 0, 5 by 2, 79 by 2, 0, 0, 0, and here 5 by 2, 7 by 2, beta minus 22 by 2. That we can write it as beta minus 11. Can we write directly? This much arithmetics you should be able to do perfectly. Then, what is the rank of this? When alpha is equal to 44, alpha is equal to 44 implies rank of A is equal to 2, because only 2 non-negative rows are there. Non-zero rows, non-negative, non-zero rows. Rank of A is equal to 2. Now, if rank of K this is the augmented matrix, rank of K that is equal to R dash should not be 2. What is the condition what we wanted? Rank of A should be less than rank of K. That means rank of K should be greater than rank of A. That implies rank of K should be equal to 3 because we have got rank of A is equal to 2. That means beta minus 11 should not be equal to 0. That is the conclusion. That means if alpha is equal to 44 and beta is not equal to 11, that implies rank of A is less than rank of K, which implies no solution. Simultaneous equations are inconsistent and no solution. That means RA is not equal to R dash. R is not equal to R dash. For the detailed explanation, you please see my previous lecture. And RA is less than N, less than number of what you call variables. This is what is the conclusion we have got. R is not equal to R dash, hence RA is not equal to RK. That implies no solution. This is the second condition what we have got. Now third case, infinitely many solutions. For infinitely many solutions, the system should be consistent, but the rank is less than number of variables. What is the condition? Consistency with rank is less than N. Consistency means what? RA should be equal to RK. RA is equal to 2 here. Last row is totally 0. RK is equal to 3 if beta is not equal to 11. If beta is equal to 11, that implies RK is equal to also 2. If beta is equal to 11, how you write the augmented matrix? You please write it. When alpha is equal to 44 and beta is equal to 11, that implies augmented matrix is equal to, how it will be? Augmented matrix with elementary operations. 1 minus half 3 by 2 with after elementary operations. 1 minus half 3 by 2, 0 5 by 2 790 by 2 79 by 2, 0 5 by 2 790 79 by 2. Let us write the expansion coefficient matrix first. 0 0 0, and when beta is equal to 11, 5 by 2 7 by 2 and 0. 5 by 2 7 by 2 and 0. That means rank of this matrix RA is equal to 2. Rank of the total matrix RK is equal to 2. RA is equal to RK but less than N. implies has infinitely many solutions, because number of variables are 3 and possible equations as per the rank are 2, hence there will be infinitely many solutions. Ultimately, what we have got as an answer, if alpha is not equal to 44 for any value of beta, it has unique solution. The system has unique solution. Second, if alpha is equal to 44 and beta is not equal to 11, that means it has no solution. Third, if alpha is equal to 44 and beta is equal to 11, it has infinite solutions. In JEE Advanced, the question can be, they may give alternatives in such a way that multiple alternatives are correct. They may give one alternative this and also this, club both of them as A and B, and they say A and B are correct, C and D are correct. That means you have to answer them multiple alternatives. Then only you will get the full marks. If you don't have the concept clearly about the finding the rank of the matrix and also the augmented matrix rank, then you will not be able to answer this question perfectly with only making determinant is equal to 0. That can be solved only for this condition, not for this condition. Now they can use interchanging, like alpha is equal to 44 for any value of beta, it has infinite solutions. In JEE Mains it can be asked like this for a single alternative. Or they can say if alpha is equal to 44 and beta is equal to 11, there is no solution. That means from this 6 types of questions can be asked. Beyond this, I think alpha, beta, gamma, using the constants inside the determinant, inside the matrix, those things, by practicing number of questions, you will be able to do it faster. Try to practice from your textbooks, many examples, or from the previous year questions, many examples, as much number of possible examples you do, and try to solve the problem fast. Here I am here to give you the concept, and this is the concept, and we have, with this I want to conclude this lecture. And if there is a value addition to you, please share and subscribe to my channel Maths and Science by IITian, and best of luck to everybody. Thank you for viewing this lecture. Thank you for listening to me. Best of luck. Thank you.